everybody, welcome. We're going to solve this question very quickly, and then we're going to apply the same ideas that were applied for the complex root of unity. Okay, so this isn't the complex root of unity, this is the complex root of 2. How do we get it? We should expect that there are 3 roots for this. So the first idea is to write this somewhat this way. We already know that 1 can be written as e raised to power pi I k. We can write this, right? We can write this e raised to power pi I 2 pi I k, sorry, 2 pi I k. We're familiar with this already. E equals to 2 pi r k. So where k is just a scalar like this, where k is equal to 0, 1, 2, 3 continuously. Okay, so now since this is 1, I can apply it here. That means that z raised to power 3 now is equal to 2 e raised to power 2 pi I k. We have it like this. Okay, now so I can now take the square root, the cube root of both sides. So z becomes 2 raised to power 1 over 3 e raised to power 2 pi I k, everything divided by 3 now. Okay, so these are the solutions. There are 3 solutions here. So of course I'm going to take k to be 0, 1, 2. Stop there because the highest power is 3. So it is always, k is always 1 short of the highest power. So that means that the first solution here, z1, is going to be equal to 2 raised to power 1. That's when k is equal to 0. When k is equal to 0, 1 over 3. Then when I put k is equal to 0 here, it gives me this, which is equal to simply 2 raised to power 1 over 3. So that's exactly what I'm going to obtain if I had solved it normally, okay, without the complex ideas. Okay, so z2 becomes 2 raised to power 1 over 3 e raised to power, when k is equal to 1 now, 2 pi I over 3. Okay, well, I'm not going to leave this like this. I'm going to simplify it further to give me 1 over 3 like this. Let me put it in polar form to give me cosine 2 pi over 3 like this, plus I sine 2 pi over 3 like this. Okay, hope it's clear. So now this becomes 2 raised to power 1 over 3. What is 2 pi over 3? 2 pi over 3, 2 pi is 360 degrees. 360 degrees divided by 3 becomes 120. So cosine 120 degrees is minus half. So I have minus 1 over 2. Then plus, what about sine 120 degrees? Sine 120 degrees is going to be equal to root 3 over 2. So I have root 3 over 2 I, like this. So that's my solution. I'm done. That's z2. Okay, z2. Now z3 is when I put k is equal to 2. So z3 is going to be equal to 2 raised to power 1 over 3. Then e raised to power 4 pi I over 3. So in the same way, I should write 2 raised to power 1 over 3, open the bracket, to give me cosine 4 pi over 3 like this, plus I sine 4 pi over 3 like this. This is very simple. So this becomes 1 over 3 like this. Now what is 4 pi over 3? 4 pi over 3 should be 240 degrees. And cosine 240 degrees, if you remember, if I work it out somewhere, this is like this, right? So 240 degrees is here, okay? And cosine is negative. Cosine is negative here. So 240 degrees, cos 240 degrees, 240 minus 180. 240 minus 180, 80 degrees gives me 0 here. 14 minus 8, 6, that will be 60. So I'm going to be minus cos 60, which is half. Then what about sine here is negative also. Sine 60 degrees. Sine 60 degrees is minus root 3 over 2i. So these are the solutions, right? These are the solutions. So I have my Z3, I have my Z1, and I have my Z2, and so on. These are the complex roots of unity, okay? Close it. Close it. Thank you.